Hello guys, welcome back to learning microcontrollers. In this video, I'm gonna show you how you can interface an LDR light dependent resistor sensor with a PIC16F877A microcontroller. And in this video, I will give you a Proteus demonstration of this project, but the hardware demonstration is not included. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. And this is an LDR sensor I'm going to use. As you can see, the LDR sensor has only 2 pins. I make one go purple, another go red. You can shuffle these 2 pins as you like, doesn't matter. Now guys, you connect one pin directly with the VCC pin of your PIC microcontroller, and for the other pin, you will need a resistor. You can use a 10 kilo ohm resistor, that's fine. You can use any resistor between 4.7 to 10 kilo ohm, like this. Now guys, you connect this other pin with any available analog to digital conversion pin of your PIC microcontroller. I'm going to use a pin number A0, and you will also ground the sensor from the same pin. Same pin will go to one end of the resistor, and from other end of the resistor this will go to the ground of the PIC. In this way your LDR is connected to your microcontroller. Now guys, next thing, I'm going to use an LED for the purpose of output, displaying the output. As you can see, this 5 mm crystal LED has 2 pins, one is longer and one is shorter. I'll make them, one go orange, another go black. Now, you cannot connect an LED directly with a PIC. You can, but it is a chance that it will get burned. You will need a resistor. 220 ohm is fine. It will limit the current and will be a safety for your LED, so it will not get burned. Now, let me show you how to wire it up. You connect your longer pin, only the longer pin. You cannot shuffle these 2 pins, remember. The longer pin is a power pin. You will connect it to the one end of the resistor, and from the other end of the resistor you can send it to any available digital input output pin. I am going to use a pin number C0. And the other pin of the LED, that is a black pin, is a ground pin. You simply connect it to the common ground of your PIC microcontroller. Now guys, to calibrate the sensor and also to display the output, I am going to use the 16x2 LCD. This LCD has 16 pins from left to right if you hold it like this. And to interface this LCD with the PIC, you need a 10 kilo ohm potentiometer. This is used to adjust the contrast of the LCD. It also has 3 pins. So the LCD has 16 pins from 1 to 16 from left to right if you hold it like this. And the potentiometer has 3 pins, black, green and red. Now guys, let me show you how to wire it up. You connect the pin number 1 and 5 of the LCD with each other, and this goes to the pin number 1 of the potentiometer, and then you send this to the common ground of the circuit. These are the grounding pins, pin 1 and 5 of the LCD and pin 1 of the potentiometer, and then you send it to the common ground. Now guys, pin number 2 is the power pin of the LCD. You connect it to the pin number 3 of the potentiometer, and from there you send it to the common 5 volt supply of your PIC, like this. In this way, potentiometer gets 5 volt and your LCD gets the 5 volt to operate. Now guys, the third pin of your LCD is the adjust contrast pin. You will send it to the center pin of your, that is the pin number 2 of your potentiometer. This will be the pin which will be responsible for adjusting the contrast of the LCD. Now guys, pin number 4 of your LCD is a reset pin. You will connect it to any available digital input output pin of your PIC microcontroller, and later in the program we will program it using this pin. Now RS is the reset pin, pin number 5 is the ground, and pin number 6 is the enable pin. You connect it to any available digital input output pin. I'm going to use a pin number 20 of the PIC microcontroller, that is pin number D1. And pin number 7, 8, 9 and 10 will go empty because we are using this LCD in 4-bit mode. And if you use the LCD in 8-bit mode, then you need these 4 pins, else you do not need them. So in our case, we don't need them. You will go straight to pin number 11, 12, 13 and 14. Pin number 14 is the data pin 7. I connected to that pin number D2 of your microcontroller. 13 is a D6, goes to D3. 14 is a D5, data pin 5 of LCD, that is pin number 12, will go to pin number D4 of your PIC microcontroller. And pin number 11 is the data pin 4. I send it to the D5 of the PIC microcontroller. In this way, our data pins are connected. Now pin number 15 and 16, these 2 pins are for the backlight of the LCD. If your LCD have a backlight, then you connect them, you will get the backlight. If you don't connect them, still your circuit will work. But if you connect them, you will have the backlight. So pin number 15 is the power pin. You send it to the VCC pin of your microcontroller, and 16 is the ground pin. In this way, your backlight LCD also gets the power. Now guys, this is our total circuit. I show you in the Proteus how to make the same on the Proteus. You will follow this wiring in the hardware. How to set up this PIC microcontroller before doing this wiring, I will share the link in the description. You can also support my channel using the Patreon link that is also available in the description. I will use that money given by you to buy more sensors and modules to make more videos. So I hope you guys look forward to it. Now let's get to our Proteus. So guys, this is our Proteus. Let me zoom it in like this. Here you have ISIS. You click on it. Let it open. Like this. Now on the left in the devices, you click on this P, write down PIC16F877A. Here you go. Place it anywhere on the screen. Now bring in the LCD, LM016. This is the LM016. Place it anywhere on the screen that you prefer. I place it here like this. Now bring the variable resistor, write down variable. These are the variable resistor. Look for the 10K one. This is a 10K trimmer. You place it wherever you prefer. I prefer placing it here. I move it a bit ahead. Now guys, we will need LED 5 mm. So these are the LEDs. Look here for the one 5 mm, blue, green, red. I take the red one. I place it where I prefer. I place it right here like this, or I can place it here because LDR will be here like this. Okay. Now we have our LCD. We have our LED. So we bring all the outputs here like this. This will be better. And LED, I move it above it like this. There will be our LDR. This will be better. Now guys, the next thing is the resistor, 220 ohm resistor that we are going to need for the LED. I place it here. And now LDR, I write LDR. This will bring this sensor called LDR generic model like this. You place it here. For the LDR, we need another resistor. You place a resistor over here like this. Now guys, let's do the wiring. First of all, we wire up our LDR. For that purpose, go to the terminals. There you have power, simulated power. You place it. And there is a ground. You place it below your circuit like this. So this will be our common ground and this will be our power. But in case of hardware, you will follow the ground of your PIC microcontroller, which I showed you in the presentation. Now guys, first of all, what we do, we connect this resistor to the power pin like this. No, you don't connect this. You have to give power to the LDR directly like this. Sorry for this. Directly one pin of the LDR goes to the power, and for the other pin you place this here. You bring it like this, and then from the same point add a point here, and you take your analog to digital pin output. This I had used pin number A0 in the presentation. I am using the same in the Proteus. Now the other pin will go to the common ground of the circuit. So you take it to the common ground, that is here like this. Now guys, in this way our LDR is connected, as simple as that. Now the next thing is the LED. LED will need power from the pin of your microcontroller. So we connect this here. Other end where there is a bar, this is the cathode and this will go to the common ground. And this is our common ground. It is going to the ground. And power pin will go to the pin number C0 as shown in the presentation, because I had selected pin number C0. So this is our pin C0. LED is also connected. Now we connect the LCD. So first of all, pin number 1 and 5 of the LCD gets common like this. Then this goes to pin number 1 of your potentiometer like this, and then this all goes to the common ground like this. Now we connect the pin number 2 of the LCD to the 5 volt pin, and for that we first connect it to the pin number 3 of the potentiometer. From there we take another wire which will go to the common 5 volt supply of the PIC like this. Now pin number 3 is the VE pin, that is the adjustable contrast pin. You send it to the adjustable pin of your potentiometer. RS pin, I had selected pin number T0 like this. goes to the pin number D0. Enable pin goes to the pin number D1 like this. And then I had left D0, D1, D2, D3 because they are for the 8-bit mode while we are using 4-bit. So D7 will be the next pin. I connected to the D2 like this, D6 to D3 like this, D5 to D4 like this, and D4 will go to D5 like this. In this way our connections are completed. LED is connected, LDR is connected, and our PIC is connected. Now we go to our MikroC for PIC to continue with the programming. So let's open up the MikroC for PIC. This is the MikroC for PIC I'm using. It's version 7.2.0. 7.5.0 is the latest one. You can also use that. Click on File, New Project. This will lead you to this window. Click on Next. Write the name of the project. LDR Proteus Demo LM. I'm using PIC16F877A microcontroller and the crystal is 20 MHz I'm going to use. Click on Next, Finish. Now before you do anything else, press Ctrl S to save your project. Save it wherever you prefer. Now the next thing is we need to initialize the LCD. For that purpose we need the LCD library. Close this, we don't need this. In the library, extract, open it. Here you have this LCD. You check this box, click on Extend. Here you have LCD I90. Double click. This will lead you to this help page. In the example, you have these commands. You copy them till here. Go back to your project and above the void main you paste it like this. Now guys, here you can see RS pin in the pin out. RS pin is a pin number B4 while we are using D0 here. You simply have to change the pin bits like this, D0, and for the enable pin, that is the enable here, we are using D1 while it's B5, so make it D1. For D7, I'm using D2 like this. For D6, I'm using D3. For D5, I'm using D4, and for the D4, I'm using D5. If you use some other pin configuration, depending upon the availability of digital input-output pin of your microcontroller, you only have to change this. Rest of the programming will remain the same. But now this is the pin direction. Do exactly the same. For RS, we have D0. For EN, we have D1. For D7, we have D2. For data pin 6 of the LCD, we are using D3. And then we have D4 and D5 like this. Now again, go back to the LCD I90 library. Here below this you have this LCD I90 initialize command. You copy it and you place it in the void main loop below the void main. Now give some delay for the initialization of this command like this. Now guys, we have our LCD initialized and by default on the LCD you have a cursor. I don't want the cursor. If you want to keep the cursor, you can keep it, but I'm going to remove the cursor. For that purpose, you go to this LCD CMD library, double click, copy this command in the example, paste it, remove whatever is in the bracket because it says LCD clear. While we want to remove the cursor only, go back to the LCD command and go to the table, available LCD command table. Here look for a command called this, LCD cursor off. Copy it, go back, paste it within the bracket like this. Now this command will turn off the cursor, which I don't want. If you want to keep the cursor, you can keep it like this. Now the next thing is we are using an ADC pin. For initializing an ADC pin, we will need the ADC library. Check mark this, and in the ADC library you click on this ADC INIT command, this command. You copy it, you paste it. This command will initialize all the ADC pins of your microcontroller. All the ADC pins are now initialized of your PIC16F877A microcontroller. Now you can use them. Now we have our LCD, we have the ADC pins. The next thing is we are using a pin for LED. That is pin number C.F0. So write down trace C.F0 equals to 0. If it is 0, it means this pin will act as an output. If you want to attach a button or use it as an input, just make it 1. Now give the initial state, port C.F0 equals to 0. Initially, the LED must be off like this. Now give some initialization delay. Now we have our LED, we have our ADC pin initialized, we have the LCD initialized. So now we can move for the forever loop. For forever loop, write down while 1, forever loop starts here and ends here. In the forever loop, first of all, we will need to read the sensor value. For that purpose, we will need a variable which will store the sensor value. For that, write down float LDR. This will store the sensor value. So go here, write down LDR, the variable we just created, equals to ADC read 0. This means this variable LDR will store the value read from the sensor from channel 0. This 0 is channel 0. You have to write this command as it. This will be your variable. This will be the command read ADC read, and this is the channel. I am using pin number A0 here. See, I am using pin number A0. If you are using A1, that is a channel 1. So I am using pin number A0, so my channel must be channel 0 like this. Now the next thing is give some initialization delay like this. 100 will be fine, or make it 50 to increase the speed like this. Now the next thing is we cannot display this raw value directly on the LCD. LCD cannot display, LM016 LCD cannot hold a float. This is a float. It cannot display a float directly. We need to convert it to a string. To convert this to a string, you first of all take a string variable LDR1. Maximum it can store 6 digits. So LDR1 is a char array of 5 digits. It means it's a string of 6 digits like this. 0, 1, 2, 3, 4, 5, 6. Now go to the conversion. We need to convert, so check mark this library. In the conversion library, you have a command called float to string. This. You double click on this command and you copy this command from here, or you can write it down, whatever you prefer, like this. Now float to string, this is the float. So we have this float. It will convert it to a string, so it will be stored in this variable like this. So whatever LDR value is received here will be turned into a char, which can be displayed on the LM016 LCD. So give some initialization delay. Now display it on the LCD, use LCD out command. From here in the LCD library, you have this LCD out command. This one is LCD out command. You copy it, it is in the example like this, and you place it here. Now this is the row and this is the column. Start writing from first row and first column. What I should write? This char. That's why we converted this into a char, a string. You cannot display LDR this directly. It will give an error. It cannot display it. It is a limitation of this LCD. Now give some initialization delay, 50 will be fine. But now first of all, we are writing a code. This code will be used to calibrate the sensor. Once we had calibrated the sensor, then we will write our actual code. So now let's build this code and run it on the Proteus and see what happens. No errors, see, it's perfect. Now let's get to the Proteus. Double click on your PIC16F877A microcontroller like this. Our crystal is 20 megahertz like this. On the desktop, look for the new codes. LDR demo, this is the code I just wrote like this. Now you click on run. Let's see what happens. See, we are getting 74 value when LDR is at 1. I increase the value and see what happens. Okay, I make it 2, it goes 126. With 3, it goes 170. In real time, it is the intensity of light falling on the LDR. I make it 4, 5, 6, 7, 8, 9, 10. I keep on increasing, the value increases. When I decrease, the value decreases like this. See? Now guys, what we do is that, suppose our LDR at 15 means that there is enough light in the room to turn on the LED. So if this value is at 454, it means it's at 15. Now we have our calibration threshold. So it must be above 450 for the LED to turn on. Get back to your microcontroller programming. Here, write down if LDR, that is an integer value before conversion, is greater than 450, then port, that is a LED port C.F0, this is a port, it is 0 initially, make it 1 like this. If it is greater than 450, you make it 1. Now else, if LDR is less than 450, then what it should do, it should again turn it off like this. It becomes 0 like this. Build this code. Now see, we have our calibration threshold. Now we go back and I pause the code we are just using, again run the code again, click on run. So now the value is 454. I bring it down. Okay, there is a mistake that we didn't change the resistor value. You have to make it to 20 ohm, 22k. Okay, it's 407. I go up. See, when it goes above 450, LED turns on. Now I bring it below, it turns off. See, when it goes above 450, LED turns on, and when we go below 450, it turns off. Now again go back to the Proteus. We use the second line to display the value as well. Now also turn on the LCD. Also copy this command, LCD out command. Here, write down, start writing from the second row, first column. What it should write? Light on, LED on, like this. And again, if it is below 450, it should write LED off. Now build this code. It's built. Go back to the Proteus. Stop. Let's run it again. Click on run. Okay, the new code is running. Now see, it says LED off. You can see that. I go up, it's LED on. It's above 454. See, it's on, whatever the value is above. Now again I go down below 450. Again it says LED off. So guys, this was a simple project using Proteus. I hope you learned something from this video. Thank you very much for your time, and the link to my Patreon page is in the link below. I hope you will look forward to it so I can buy more sensors and modules to make more videos. So guys, thank you very much for your time and interest in my channel. Have a nice day.